Somebody's asked about this in the discussion board. I'm pretty sure I did this in one of my lectures, but I've noticed that some of the lecture recordings haven't been loading correctly. So I'm going to run through it one more time, plus it hits on a key concept. Find the Taylor series for this. The question that the student is asking about part B, but let's just run through the first part. This should be really fast. I'll try. I always can't help myself but to explain a little bit. But ultimately, this starts with the known series that we have. This is the one with all the odd powers and the odd factorials. Sine is an odd function. We talked about that a little bit. And then, we'd like to eventually move past writing out the first few terms. But if you're still struggling with the notation, let's write out the first few terms. And I would encourage you to do that on the test as well to check your reasoning. Okay, so the real question is, what are we plugging in for z? The thing we're plugging in for z is x squared. So the answer should be x, there's an x on the outside, times the sum from k equals 0 to infinity. And all we're doing is putting an x squared here. And I strongly encourage you to simplify that. You really want to. So the first thing I would write is x to the 4k plus 2. Everything else stays the same. So this is negative 1 to the k. This is 2k plus 1 factorial. And this is x to the 4k plus 2. And you should also know that when you distribute the x, and this is where the notation can help, the dot, dot, dot notation. Because if you had just, because sometimes people go, I don't know what to do with the x on the outside. Well, that's when you can come over here and say, well, if I'm unsure what I'm allowed to do, let's put an x squared in there. So I'm going to have an x squared minus 1 over 3 factorial. I'm going to leave some space. 1 over 5 factorial. And this is just for those people that still are unclear about this piece. So we're putting an x squared in there, so it's going to be x to the 6th. We're putting an x squared in there, so it's going to be x to the 10th. X squared to the 3rd. Okay. Now, what happens when you multiply by x? It increases it all by 1. So this is going to be x to the 3rd. This is going to be x to the 7th. This is going to be x to the 11th. What does it do to the notation? It increases this by 1. So let's just do that all in 1. This is 3. And if we're having trouble, the first few terms are x to the 3rd minus 1 over 3 factorial x to the 7th plus 1 over 5 factorial x to the 11th. And let's say you wanted to get the next term. This was k equals 0. This was k equals 1. This was k equals 2. Let's now spit out the next term. Let's put in a 3. What happens if you put in a 3 here? If you put in a 3, the question didn't ask for this. The next one's going to be x to the 15th. And then in front of it, you're going to have a negative 1 to the 3, which is just negative 1. I already have the negative there. And then you're going to have 2k plus 1. So 2 times 3 plus 1. Let's see, that's 7. 7 factorial. Okay, that makes sense. And then it keeps going. You can start to see the pattern. Blah, blah, blah. Okay, so the question was about part B. So part B is trying to connect our two worlds. And what do I mean by that? Well, we have two different ways we can find this Taylor series. So let's recap the other way. And again, you're not going to actually do this in the problem. It's a very short problem. And again, this first part should have been very short. We really could have done part A in a matter of like 20 seconds if we understand what we're doing. Because all you're doing is plugging in x squared here, simplifying, and then multiplying times x. That shouldn't be a long problem. But let me review. So once again, the other way we could do this is to take lots and lots and lots of derivatives. Now this would require the product rule. This is absolutely terrible, but I'm going to do it a little bit just so you can see. So I just did the product rule, and now I'm going to keep going. into the second derivative. So it's going to be 2x cosine of x squared. And then I do the product rule. It's 4x cosine of x squared, and then minus 4x cubed sine of x squared. And you could construct this thing the long way. And the only reason I'm saying this is to explain what part B is asking yet again. Okay, so what's happening? If I plug in a 0 here and a 0 here, I get 0. If I plug in a 0 here and a 0 here, I get 0. If I plug in a 0 here, this is 0. Because the cosine is not 0, but because the x, these are 0. Well, shoot, this is taking forever. Let's go one more. And that I really will have reached my limit. The second derivative so far is 6x cosine of x squared minus 4x cubed sine of x squared. Okay, so now I want to take the third derivative. The third derivative is 6 cosine of x squared plus 12x squared. It should be minus, and then this other big mess, minus 12x squared sine of x squared, and then let's see, minus 8x to the fourth cosine of x squared. And when I plug in 0 everywhere here, I actually get 6. So I finally got something. 6. Okay, let's simplify that. What is 6 over 3 factorial? It's 1. Notice that that matches the number we have here. So let's kind of summarize what we just found. We just found out that if you do 1 over 3 factorial times the third derivative at 0, you get the same thing as the number in front of x to the third. And we happen to already know that number from before. So we know that that number is a 1. And that allows us, if we wanted to figure out what that should be. That has to be 6. Let's keep going. Let's play the game again. Let's say we wanted to know the 7th derivative. The 7th derivative of this at 0 divided by 7 factorial should be the same as the number in front of x to the 7th. Now this time the number in front of x to the 7th is this. So what can we conclude from this? What we can conclude from this is that the 7th derivative at 0 must be negative 7 factorial over 3 factorial. So if I had kept going, that's what it is. Okay, that's not what the question is asking. The question is asking about this. And so here's what you do. You say 1 over 507 factorial, and don't actually calculate that. 507th derivative at 0 is equal to, and the thing you need to find is the number, the coefficient in front of x to the 507. Okay, so that was the long explanation of why it works. Let's erase this and go back and show you how short this question is. And then these hopefully won't scare you anymore. So let's recap and pretend we're fresh. We're doing this problem as if we're a student. The first part of the question, we wouldn't have done any of this other mess. We would have just written the answer and been done. But we would have simplified. So we would have distributed the x just like we did. And then we get to this question and we say, oh yeah, this is this thing. I just need to know what happens when we get to x to the 507. So it's really a question about notation. When are we going to get a 507 right here? And so really your job is to solve when is 4k plus 3 equal to 507. And that's when 4k would be 504. And that's when k What would that be? I'm going to do some long division. I don't want to get a calculator out. So this goes in here one time. I should be able to do this in my head, but I've answered about 100 questions today. So I'm running on the last of my sanity. So this is subtracting. It's 24. So I'm getting 128. I don't trust myself. 1, 4, 10, 2, 8, 24. No, it's 6. See, I really shouldn't trust myself. Okay, so this is 126. So now I'm going to plug 126 everywhere with the goal of figuring out what the number was in front of x to the 507. It turns out it was -1 to the 126 divided by 2 times 126 plus 1 factorial. If I simplify that, -1 to 126 is just 1. And the denominator is whatever 2 times, I'm having to do some multiplication, 2, 1, 5, 2, 252, plus 1, 253. That sounds like a good area code for those of you from the Tacoma area. That's the number in front of here. And now I'm ready to answer the question. The 507th derivative at 0 is 570 factorial over 253 factorial. Now let me know if I made a typo or something, but that's the idea. So sorry, there's just no short way to say that, so I just want to make a video. I did that exact problem in one of my lectures, but I don't know if the recording is up, so I thought I would just do it again. All right, hope that helps.